Okay, so we're going to evaluate this integral, this definite integral between 1 and 2 rather. There's the integrand, and we're going to use a technique which decomposes the integrand into partial fractions. Now it's often a good idea, always a good idea if you can, to estimate what the answer is going to be, so if you do evaluate it then you've got some feel for it. In this case, what you would do is you'd look at the integrand when x is 1 and look at it when x is 2 and see whether you can perhaps guess what the integral would be. If you put x as 1 in, you get a 1 over 1 times 2, a half, basically the integrand's a half. When you put x as 2 in, you get 2 over 3, which is a sixth, so about 0.166. So the integrand's 0.5 at one end and 0.166 at the other, so let's take the average of that, say 0.33 or so. So a rough guess at the answer is going to be 0.33. Alright, but let's use partial fractions to get an exact answer. So what we'll do is we will write this and then write the integrand. I'm putting the exactly equals sign because this has got to hold true for all values of x. I'm going to assume you can break it into a over x plus b over x plus 1. Okay, so the technique normally goes, we're trying to solve for a and b is what we're trying to do here. Then we won't have any problems with these as integrals. Alright, so multiply both sides by the denominator here. X plus 1 gives us 1 is always equal to a by x plus 1 plus b by x. Okay, now what do we do? This has got to be true for all values of x. There's two ways of doing this. You either substitute in a value which kills off one of the terms, so you either substitute in x as 0, which we can immediately see is going to simplify this to just that term disappears, and that's just a. So a equals 1, so I'll just write a equals 1. And b, if we substituted in negative 1, we would kill off that term. That's the idea of why we've chosen negative 1. And we get minus b equals 1, so b equals negative 1. Okay, so rewriting the integral, we have 1 to 2 are the bounds, and we've got 1 on x minus 1 on x plus 1 dx. Alright, now this is the spot you check. You put this back together in your mind. X plus 1 cross multiplying would give x plus 1 minus x is 1 would be the numerator and that would be the denominator, which is correct. So that's right. Next step now is to simply just to integrate each term, which is log 1 on x is log e, the x, minus log x plus 1. Now you often see this written with a mod around it, around the argument. In this case we're integrating from x is 1 to 2, so x is always going to be positive, so I don't really need that. So I'll just write this, just to be careful, write this as from 1 to 2, but then we might just put this together and write this as log x over x plus 1 between 1 and 2. Okay, and basically almost there. Just got to put the 2 in, evaluate it at 2 and evaluate it at 1. So you get log, I'll just write e in up there just so it's correct, 2 over 3, that's evaluating at x is 2, minus log e, and that'll be 1 over 2. Okay, so can we do anything with this just to make it a bit easier? We can put those two logs together and write that as log 2/3 divided by, because there's a minus there, when I put this together I'm going to end up timesing by the reciprocal of this times by 2 over 1, which equals log 4 over log 3. Okay, that is going to be a fraction, that's less than 1. And if you use a numerical integration tool or you use a CAS, you'll find that that is the correct answer.